Okay, gents, hopefully you can have a look at this before your lesson this week. It's first week back after half term. Mr. Conroy's group, Mr. Conroy won't be in this week, and so you'll be having Mr. Rutter instead. Mr. Rutter is not a electronics specialist, and so he can give you limited help. That's why I've put together this video, so that hopefully you can understand the process, or the next process is, in completing your dice, your random dice that you're making at the moment. I'm not completely sure, I'll be honest, where my group is and where Mr. Conroy's group is. I know you're floating around breadboarding. I know you're floating around putting together the mask for the PCB. I know that. And I've just had a lesson, and it was a split of about 50-50 between those two things, those two exercises. Now, in regards to the breadboard, there is limited help I can give you. I think you probably all know that you need to connect your Genie, you need to get your LEDs arranged in the right manner with the right ones connected together, and then the outputs from your Genie will be controlling which LEDs come on depending upon how you've programmed it. So that, I think, if you haven't done, you probably can do. It's just a case of you not spending enough time in the department to get all that completed. So moving on to the next challenge, the next exercise, we are drawing up the PCB, the PCB mask, I should say, and I've got a couple of different documents here. I'm not too sure, I'll be honest with you. Yeah, there's one of them. It's one of them, and you could see the other one just a few seconds ago. So we've got a list for PCB. This is the list for your mask. And what do I mean by your mask? I mean the black and white thing you often see around the department that is used to cut your PCB. And it's that it uses light to do that, and also an acid. But before we go into all that, I think that's probably best saved for another day. I just want to show you this little checklist in regards to, have you got this on your PCB? The high pads plus the strain holes, there to be 5 of those. Low pads plus strain holes, 6 of those. Input pads, rah. Okay, so what you need to do is, when you design that PCB, is go through this and make sure that you've included each one of these different components. Okay, that's really quite easy. Now let's go to the circuit wizard diagram, and let's just dive into this a little bit more and sort of work out what we're doing. So what do we got? Well, essentially on this we have a Genie. I'm going to, for the time being, take away that background, because I don't think that background makes it any clearer. You can see what I've highlighted. That is my Genie 14. Where do I get that Genie 14 from? I get it in a very similar way. I go down to microcontrollers, if I can find them, microcontrollers, and then I get the Genie 14, and all I do is I grab it and I pull it in. And that's exactly how I've done, or I've pulled each one of these components into the page. So what have I got? Well, I've got my microcontroller in the middle highlighted. I've also got this programming port. Programming ports are under sockets. The first thing I've done is I've linked the middle pin, which is the status pin on the programming port, to the status pin on the microcontroller on the Genie. What have I done next? Next, and how you do this is up to you, is linked the programming side, and can you see download socket, programming input. I've linked that pin, or those two pins are joined together so they're the same pin, to the programming port on the Genie. Now I need to use a current limiting resistor to do that. and that's why it's going through a 22k resistor. But remember, when that goes high and low, we have a bit of fuzzing electrons around, we have a bit of floating voltage, and so we need to pull that low. And can you see also what I've got is a 100k resistor straddling the status track and then going to the low side of the circuit. How do I know that's the low side of the circuit? Well, can you see here, if we follow the track around, I've got my pad connected to the low side of the power, along with a high pad up here connected to the high side of the power. Where do I get the power from? Again, I can go down here and I can look, I think it's right at the top. Power supplies, we can bring them in. I think also this is actually an off-board component, so if you keep on going down, I've got power supplies there. Can you see that these power supplies can just be taken in? There we are. Can you see? I won't do it because it's going over. Yeah, good. Right, so we've put our programming socket in and we've connected it to the Genie through a 22 and 100k. It's really important that we do that. Right, next up, we need to connect the Genie to the high and low side of the circuit. We're going to do that by putting a switch in here. We need one side connected to one pin and the other side connected to the middle and the other pin. Okay, if it's a 3-pinned single pole, single throw switch. Okay, what that allows me to do is when I play it, if I tap on it, sorry, I'm not playing it. Oh, it's saying incorrect program. Right, I obviously can't play it. It allows me to switch it on and off. The power will be going to the high pin of the Genie, which is pin number 1, and when you flick that switch, the power, it goes to the pin number 1 or does not go to pin number 1, depending upon the position. Equally, we've got the low pin going to the low side of the Genie. Okay, so now we've got power to the Genie, we've also connected it to that programming socket. Finally, all we need is inputs and outputs. How do we do that? What I have done, and this may be a little bit confusing, is no matter how many inputs you have, they're all going to be taking their highs from the high side of the circuit. Excuse me. The low side of that input is going to go to individual pins. They're not all going to go to the same pin, of course. And so they share almost a common source, a common high, but the low leg of the push to make switch will go to specific tracks so that you can make specific pins go high and low. Therefore, what I have done is I have located 5 different highs away from the highs of the Genie, just because it gets rather congested around here. And if I was to put another one of these in, another switch in, I would connect it to the high up here, and then my leg here would be going to, for example, D0. So when I press that now, what happens is that track goes high. Okay, I'm going to take that off. So I've got 5 high pads. Where do I get the pads from? I get them from here. Where do I get the tracks from? Get them from there. Okay. Now, just as before, that's all okay, but when this track goes high and we take our finger off the push to make, it doesn't go completely low, and therefore we need a pull down resistor. Pull down resistor needs to have more resistance than the chip, than the microcontroller, and I'm always saying 100k is quite a good value for a pull down resistor. Okay, so we have our track going to the specific pins, also linked to a pull down resistor. Where does that pull down resistor need to go? It needs to go to the low side of the circuit. So we have a little bit of a problem in that this side is the high side of the circuit and this side is the low side of the circuit. I can't go around the front here because I need to plug my Genie plug and play cable in. Therefore, cunningly, what I can do is I can go through the middle of that component, and that allows me to have this low supply on the left hand side of the circuit. Okay, and that's really useful, that low supply, because I can have all of my pull down resistors going to it. All right, and in this instance actually I've put the low pad there. Often what I do is I put the low pad up here, okay, feeding the low, and the high will be feeding the high, but in this instance I put the low pad down there. All right, so we got the pads coming in from the low leg of the push to make. We've got the tracks feeding the individual pins of the Genie. We've got our pull down resistors going to the low side of the track. Now, can you see this cable here? When I pull on that push to make, those cables are going to be pulling on my soldered joints, which isn't good. Just as you made your programming sockets when you drilled that bigger hole and you threaded your cable through, what I need you to do is do exactly the same for each one of your output components, or each cable of your output components, I should say. So this cable here needs to go through a hole that we're going to create, and we denote that hole in the board by a square pad. How do we do that? If I go onto here and I create, what I've done is double click on here. What I can do is I can set that to round, and this wasn't working the other day. Let's see if it works today. No, it just keeps on doing it, does it square. But you can change your pad. I think if I go to properties here, I can change it to square, and then it's a case of copy and pasting it wherever you want. Okay, I think that's pretty obvious. I hope your program doesn't have that glitch that mine's got in it. Right, so you need to provide a square pad for each place where a cable for your input components is meeting the board. Okay, I hope you understand that. Let's move to the output components. Right, output components for this project are the LEDs. We have, this is actually an output, and it's on leg 13. It's the status, and it is Q0. I would ignore that. I don't particularly like that pin. I would ignore it. So what have I done? I have created 5 different outputs. I'm only needing 4 of them, of course, because if we go back in the booklet, there is the, let's just zoom out. We need that one to come on when it's 1. We need these 2 to come on when we're symbolizing the number 2. When it's 3, we need that middle one and those 2 to come on. When it's 4, we need those 2 and those 2, so that's our 3rd output to come on. When it's 5, we need the middle one, those 2 and those 2, and then when it's 6, we need 1, 2, 3, 4, 5, 6, so those 2 need to come on as well, because that's our 4th output. Okay, right. So, how do we do this? We create a track, and you can see what I've done is I've put a track here, I've put a pad in. I'm just going to show you this. I've put a pad in, and what I'm going to do is I'm going to change that so you know that it is circular. Okay, copy paste. I could have put another pad here. Can you see? That is the spacing, but of course the pads are touching. So what I need to do is leave 1 unit between each pad. Okay, and then I do another one, and then I do another one like that for my 4 different outputs. What I do, on my 5, I should put another one in. What I'm doing next, of course, is there should be a straight track going back to the chip, and then what you can do is angle, always at a 45-degree angle, your tracks so they meet those pads. All right, I don't mind how it's done. There is another way that you can do it, which is, that would be the first one, and then the second one comes in like this, third one comes in like this, fourth one comes in like that. You can do it like that as well. Okay, so we need to connect 5 pads which will have the high leg of our LEDs touching them, or will be connected to them, soldered to them. Right, once we've done that, we also need a low. Just as there was a common high here, sorry, that's wrong. Just as there was a common high here, we can also have a common low. And that common low is a series of pads all connected to the low side of the circuit. And you've got those down here. All right, this is a bit easier to understand. Now, because these are off-board components and they have a cable, we need to have that cable going through a strain hole, and again, that's why I've included, for each one of these pads, I've included a hole in a square surround, in a square pad, so that I can drill this a little bit bigger, and that will allow me to thread the cable through, the plastic of the cable through, before putting the metal of the cable through the board and soldering it to the copper pad on the other side. All right, so I hope that is self-explanatory, or that's explained that. What else have we got? We've got the high from the circuit, which we've spoken about, with the strain hole. We've got the low from the circuit without a strain hole. So before you see that, I'm going to bring one in down here, and we've got a strain hole for him as well, or her, or they. Now, is that it? What I haven't done is draw my copper area. How do I do that? I just pull a area, and this is good for what reason? It means the chemicals aren't eroding or etching all of this out, which means the chemicals will stay useful for a longer amount of time. Every time they start to react with the copper, they lose a certain amounts of their ability to react and remove, and so we don't want to be removing all of the copper if we can help it. I think that is about it, gents, and therefore I'm going to stop there. I'm going to produce a new video after this, just looking at how to wire up the LEDs, but you can look at that at a later date. I hope that's been helpful.